Determine whether the series, which is adding up from 1 to infinity, the sequence 2 plus sine of n to the n, yikes, is convergent or divergent. Okay, pretty standard fare. Somebody brings you a sequence, say, hey, can I add this up or not? So when we think about, hey, how do I tell if this is convergent or divergent, we might start thinking, does this look like a sequence that is well behaved, something like geometric? And if we start running through the list of the ones we know, no, this very clearly is not well behaved like one of those that we can even evaluate, even though the question's not asking us to evaluate. So then we start thinking, okay, well, you don't always have to evaluate, you don't always have to have a really nice form if you could apply convergence tests. Convergence tests are designed to look at the sequence itself and be able to say, well, based on this, I know that it'll converge, or I know that it'll diverge. So let's look a little more closely at 2 plus sine n to the n. Now, right away, I'm looking at that n to the n, and that's crazy, right? 1 to the 1, oh, that's fine. 2 to the 2 is 4, 3 to the 3, 27, 4 to the 4, 256, 5 to the 5, 3,125. This is growing crazy, but it's put inside a sine. So even though my eye is drawn to, yikes, look at that crazy thing, it's stuck inside a sine. And it doesn't matter what goes into sine, whatever comes out is going to be between 1 and minus 1. So we can start to observe that right away. And we can start to slowly set up like a little inequality here, right? And then we're adding on 2. So we can definitely say the sequence we're adding up, 2 plus sine n to the n, is between 1 and 3. Now, this is true, you might say, for all n. Okay? So it's a nice little inequality. There are plenty of convergence tests out there that work with inequalities and things like that. But one thing we could say right away is, hey, these values are always at least a certain size. They're always at least 1. So it doesn't really matter what n is. Eventually you're adding, it's even worse than adding up 1 plus 1 plus 1 plus 1 plus 1. You're adding up numbers that are guaranteed to be even bigger than 1. And yeah, 1 plus 1 plus 1 plus 1 plus 1, keep going, diverges. So if we're adding up bigger things, this is going to get even bigger. We can pretty quickly conclude divergence. Now, if you do want to write it up nice and neat with a convergence test, what you might say is something like the nth term test, right? Because the nth term test says the only way you're going to get convergence is at, and this is not a guarantee, but if you've got convergence, let's say it this way, the nth term test is based off this idea that if you've got convergence, then this sequence must have a limit of 0. Okay? Now, I don't actually know if 2 plus sine n to the n has a limit. So you might say, well, then you can't talk about nth term test, right? Either it doesn't have a limit, I'm pretty sure it doesn't, or if it does, we can sort of pretty quickly say, well, then whatever the limit is, just using inequalities with limits, then the limit would be between 1 and 3. So even if there is a limit, it's definitely not going to be 0. And so the nth term test says if your limit doesn't exist or it's not 0, you're divergent. So if you really want to write it up with a convergence test of some sort, okay, there we go, we might say the following. We say, okay, so observe, I've already written this down, but we'll say observe minus 1. I'll just really quickly, it doesn't hurt to really quickly do the inequality again. Adding 2 to both sides, we get 1 here. Okay. So observe that, and then I would say something like, if I wanted to write it up nice and neat, which, if the question was just saying converge, diverge, I would say, look, everything's bigger than 1 plus 1 plus 1 plus 1, so yeah, of course it's going to go crazy and go off to infinity. But here we go. So I'd say either, so notice that either the limit of my sequence doesn't exist, that is an option that I'm not going to bother with, but either it doesn't exist or it equals L, and we can say L has to be between 1 and 3. How could this sequence approach a value like 4 when it can never even get above 3? Okay, so we can definitely say that using inequalities. If you want to invoke a result, you can say, look, if you got one sequence going to L and another sequence going to M, and you know that the ANs are always less than the BNs, then you can guarantee that L is at least, is at most M. Okay? So if you wanted to bring in like limit law theory or knowledge of limits and inequalities, you definitely could. I would say it's pretty clear. Either this doesn't have a limit, I'm pretty sure it doesn't because of the sign ping-ponging back and forth, but I don't want to get into that. So either the limit doesn't exist or it's some number between 1 and 3. So in either case, so I'll say in any case, the limit of this sequence is definitely not 0. So by the nth term test, sometimes called the divergence test, but I prefer nth term test. So by the nth term test, we can see this series, this summation, diverges. All right, so there, if we want a proper, nice, neat explanation, there you go. We've got two cases. Either the limit doesn't exist or it's stuck between 1 and 3. No matter what, you don't have a limit that's equal to 0. So nth term test swoops in and saves the day.